What if Earth's temperature rose by just 5 degrees Celsius? Not 50, not 10, just 5. It may sound small, barely enough to change your day, but it would be enough to end entire cities, drown coastlines, trigger mass extinction, and rewrite life as we know it. Picture the American Midwest turning to desert, the Amazon rainforest bursting into flames, and over 1 billion people fleeing unlivable zones with nowhere left to run. Crop failure, global famine, unstoppable wildfires, collapsed governments, and wars over drinking water. Scientists warn, we're already on track. Some say the tipping point is closer than anyone admits. But how would it really unfold? Who survives and who doesn't? This isn't science fiction. It's the future we're racing toward. Hit like, subscribe, and let's go. Right now, the average global temperature has risen just over 1.1 degrees Celsius since pre-industrial times, and already, we're seeing the consequences. Melting glaciers, rising seas, record-breaking heat waves, and once-in-a-century storms now striking every few years. Scientists around the world, from NASA to the IPCC, are sounding the alarm. If we cross 1.5 degrees Celsius, the risks multiply. 2 degrees? Catastrophic. But 5 degrees, that's a different world entirely. Today, billions of people still live under stable climates. Crops grow with seasonal rhythm. Oceans, though warming, still support life. Major cities function. Trade, travel, energy grids, while fragile, still hold. But all of this depends on a delicate balance. A few degrees may not seem like much, but Earth's systems are fine-tuned. We are, in a way, living on the edge, and many don't even realize it. The truth is, global warming isn't linear. It's a chain reaction. As Arctic ice melts, sunlight no longer reflects but gets absorbed, warming things faster. As forests die, they release carbon instead of storing it. As permafrost thaws, ancient methane escapes, gas 80 times more powerful than CO2. These feedback loops are already in motion. And the real question isn't just, can we stop it? It's, what happens if we don't? This video dives deep into what a 5 degrees Celsius hotter planet would look like for cities, for oceans, for food, for you. A future that feels distant, but might be closer than we think. The warning signs didn't come out of nowhere. As early as the 1800s, scientists like Svante Arrhenius were already calculating how carbon dioxide could warm the planet. Back then, it was just theory, an obscure curiosity in dusty journals. But as the 20th century rolled in, coal plants rose, cars filled the roads, and oil became the bloodstream of civilization. By the 1950s, a quiet revolution began. A scientist named Charles Keeling started measuring CO2 from the pristine air atop Mauna Loa in Hawaii. His graph, what we now call the Keeling curve, revealed something stunning. The numbers weren't just rising, they were accelerating. Fast forward to the 1980s, satellites began scanning the planet, confirming what early measurements feared. Our world was changing. Still, many looked away. Profits, politics, and disbelief drowned out the warnings. And by the time the world began paying attention, it was already too late to reverse course. We were locked into warming. But 5 degrees, that wasn't even in the models at first. It was a worst-case scenario, something scientists barely whispered. Now it's a possibility. With emissions still climbing, with ice sheets melting faster than predicted, with forests no longer absorbing but emitting carbon, the path to a 5 degrees Celsius world no longer looks impossible. It looks likely, unless something changes drastically. And what's terrifying is that each new degree doesn't just make things hotter, it reshapes the entire planet. If history shows us anything, it's that we saw it coming, and chose not to stop it. At 5 degrees of warming, the world stops resembling the one we know. This isn't a distant, cinematic nightmare. It's a measurable future, backed by data, unfolding piece by piece. Right now, over 600 million people live in coastal areas less than 10 meters above sea level. A 5-degree rise would melt both the Greenland and West Antarctic ice sheets, raising sea levels by more than 10 meters. New York, Miami, Tokyo, London gone. Not underwater in theory, underwater in reality. In the US alone, over 13 million people would be permanently displaced. But it doesn't stop with rising seas. At 5 degrees, the global average mass extremes. Some regions, like the Arctic, could heat up by 10 degrees Celsius or more. That means deadly heat waves sweeping across Europe, the Middle East, and the American South. Wet bulb temperatures, where the body can no longer cool itself, would make large parts of India, Southeast Asia, and the southern US literally uninhabitable for humans. Imagine stepping outside and dying within hours. Now add crop collapse. Wheat, rice, corn, staples of global food supply, begin to fail at scale. Famine spreads. Supply chains shatter. Prices surge. Countries fall into chaos. Climate-driven migration skyrockets. Over 1 billion people on the move, fleeing regions that can no longer support life. Borders tighten. Conflicts ignite. Entire ecosystems vanish. Coral reefs bleach out. Rainforests burn. Species that took millions of years to evolve disappear in decades. And all of this, remember, begins not in the distant future, but within the lifetime of someone born today. This isn't tomorrow's problem. It's happening. Now, here's the part most people don't realize. The Earth has been 5 degrees warmer before. But the last time that happened was 56 million years ago. There were no humans, no cities, no civilization. It was the Paleocene-Eocene thermal maximum, a time when the Arctic had palm trees, the oceans turned acidic, and mass extinctions wiped out species across the globe. It took Earth over 100,000 years to warm that much back then. This time, we're doing it in less than 2 centuries. That speed is what terrifies scientists. It's not just how much we're warming, it's how fast. Ecosystems don't have time to adapt. Neither do we. And the truth? The Earth doesn't warm evenly. Climate systems behave like a giant, chaotic machine. A small shift in one part, a melting glacier, a collapsed ocean current, can trigger massive disruptions elsewhere. For example, the Atlantic Meridional Overturning Circulation, a key ocean current that regulates heat and weather patterns across the globe, is already slowing down. If it collapses, parts of Europe could plunge into deep cold, even as the rest of the world burns. Meanwhile, thawing permafrost in Siberia is starting to bubble with ancient methane, a greenhouse gas far more potent than CO2. Some scientists fear this could trigger a runaway effect, a tipping point, beyond which warming spirals out of control. And here's the twist: many of these feedback loops weren't included in early climate models, which means the reality could be even worse than predicted. We're not just playing with fire, we're accelerating it, and no one knows exactly when it will break loose. Today, we know more than ever about the delicate balance that keeps our planet stable, but we're also learning how close we are to losing that balance. Scientists are constantly improving models to predict the impacts of climate change, but the complexity of Earth systems means that surprises are still possible. One groundbreaking tool is the use of satellites to measure the Earth's energy budget. These satellites can track the amount of heat the planet absorbs and releases, offering real-time data on how much the Earth is warming. Scientists also use ocean buoys to measure heat and carbon absorption, allowing us to better understand how much of our emissions are being stored by the oceans and how much are being released. This is vital, as the oceans are both our greatest buffer against climate change and a key factor in amplifying its effects. Recent breakthroughs in artificial intelligence have enabled climate models to become much more accurate. AI can now process data faster than ever before, simulating countless scenarios to predict how different regions will respond to warming. These models reveal some unsettling facts. Cities built in the last century may become uninhabitable within just a few decades. Another exciting field is geoengineering. Scientists are exploring controversial solutions like carbon capture and solar radiation management. However, these technologies come with serious risks and uncertainties, and many believe that relying on them might be more dangerous than reducing emissions in the first place. Still, without these advancements, we would have far fewer tools to predict the future of a 5 degrees Celsius world. The question now isn't whether we know enough, it's whether we're willing to act in time. As we stand on the brink of a climate disaster, we face a crucial question: what's the cost of progress? And can we fix what we've broken? Or is it too late? Some scientists argue that humanity's innovations, our burning of fossil fuels, our demand for limitless growth, have tipped the scales too far. We've already crossed many of the Earth's boundaries, and the consequences are unfolding in real time. But others take a more optimistic approach. Some theorists believe that humanity's ingenuity and technology could still turn the tide. They point to breakthroughs like renewable energy, electric vehicles, and geoengineering solutions like carbon capture. If we can reduce emissions fast enough, they argue, we might just pull back from the edge. However, this comes with its own set of dangers. The rise of geoengineering, for example, has sparked fierce debate. While some view it as a lifeline, a last-ditch effort to reverse the damage, others warn that tampering with Earth systems could make things worse. What if a solar radiation management scheme backfires, cooling the planet too quickly and disrupting global weather patterns in ways we can't predict? What if carbon capture technologies aren't as effective as promised, leaving us relying on flawed solutions? Then there are the political and economic forces at play. Some countries, despite knowing the consequences, continue to invest in fossil fuels. Others argue that the global economy is too entrenched in carbon-based energy to transition quickly enough to avoid catastrophe. This is where the tension lies, the cost of change versus the cost of doing nothing. What will it take for the world to act? Can we innovate our way out of disaster, or are we just delaying the inevitable? The truth is, we're already seeing the effects of this looming crisis. But what does a 5-degree warmer world mean for people, for the planet, and for the future of science? Imagine the world's most densely populated cities, New York, Tokyo, Cairo, swamped by heat and rising seas. Entire populations forced to migrate from coastal areas, urban centers, and agricultural zones as the land they've lived on for centuries becomes inhospitable. But it's not just the physical destruction, it's the psychological toll. People forced to flee their homes are facing a new kind of trauma, displacement on an unimaginable scale, creating millions of climate refugees. Meanwhile, ecosystems, once thought to be stable, begin to collapse. Coral reefs, home to a quarter of marine life, begin dying off at an accelerating pace. Entire species of wildlife vanish, unable to adapt quickly enough to the rapidly changing environment. Humanity's response, our greatest strength and weakness, becomes evident. In the face of overwhelming destruction, innovation may become our salvation. But for every solution, whether it's geoengineering, renewable energy, or carbon capture technologies, there's a harsh reality. No solution comes without risks. For instance, the unintended consequences of solar radiation management could alter weather patterns so drastically that agriculture in large parts of the world becomes impossible. The climate models we once relied on may no longer be trustworthy as they fail to account for the speed and unpredictability of change. The question remains, are we prepared for the unforeseen costs of this progress? The shocking truth is, humanity has become both the creator and the destroyer. We've created a world where technology can either save us or doom us to a future we can't control. As we approach the tipping point, the real question is whether we'll be able to face the consequences of our actions, or whether it will be too late to change anything at all. As we reach the edge of this precipice, the central question becomes clear: what path will we choose? The reality is that humanity now faces a choice, one that will define our future. Do we continue down the path of reckless consumption and unchecked growth, or do we take the difficult steps necessary to alter the course of our fate? The technologies that we've created, the innovations that have powered civilization, are now either our greatest hope or our greatest danger. It's a paradox. Our very advancements in science and technology have given us the tools to destroy the planet, but they also offer the potential to save it. Carbon capture, renewable energy, geoengineering. These are the solutions we must consider. But with them comes an undeniable risk. The same way we've pushed Earth to the brink of collapse, we may inadvertently push ourselves over the edge with these technologies if we're not careful. It's a choice between taking responsibility for the world we've created and accepting that we've lost control. Will we adapt, using technology to work with nature, not against it? Or will we take the easier, more dangerous route, hoping that innovation can always fix the mess we've made? The challenge is clear: to evolve, to innovate, and to act with foresight or face the consequences of inaction. But time is running out, and every moment that passes without decisive action brings us closer to a future we might not survive. Humanity has always been capable of extraordinary change. Now, the question remains, can we change fast enough to ensure that we don't lose everything? The choice is ours to make, but will we make it in time? We've talked about what's coming, the science, the facts, the warnings. But now, I want to ask you something. What if this is real, not just a theory, not just a distant nightmare, but something that could happen to you, to your children, your grandchildren? What would you do if the world you know, your home, your community, was suddenly no longer safe? Imagine watching the places you've loved for a lifetime, beaches, forests, cities, disappear, slowly at first, and then all at once. Imagine the fear of waking up one morning to find that the temperature has risen another degree, and that small, invisible shift is the beginning of something irreversible. This isn't a story from the past. This is the world we're living in, and we have a choice. We can turn a blind eye, hope that someone else will fix it, or we can face the truth and act. The reality of climate change is no longer something that happens somewhere else. It's here. It's now. And it could be happening to us sooner than we think. But it's not too late. Not yet. The path forward is difficult, uncertain, but it's ours to choose. We can still decide what the future looks like, but that decision comes with responsibility. I'll leave you with this. If not us, then who? If not now, then when? Share your thoughts in the comments. What's your plan, your hope, your fear? Because the truth is, this is all of our fight. The future is unfolding right now, and we're all part of it.